In my previous video, I discussed cash flow indexation in terms of nominal, monetary, and real values and yields. And in today's video, I'm going to follow on from that by discussing this formula over here, how to use it, how to derive it, and then I'm going to go through an example that uses the formula. Okay, I do suggest that you go and refer to my last video before you watch this video, just because it'll make the understanding significantly easier. Okay, so let's move on to how we should derive this formula. So if you recall from my last video, you'll know these following two formulas. The first one being that our monetary value, capital CT, is equal to our lowercase value, our lowercase c for our nominal value, CT, which is multiplied by our RPI at t minus lag over our RPI value at naught minus lag. Now, RPI simply stands for Retail Price Index, and it's an indexation that we use to link our cash flows to so that they take into account prices in an economy. Okay, and then you would also recall the formula for the real values, RT, which is equal to the monetary values, capital C of T, multiplied by Q of T naught over Q of T. Okay, so what we essentially want to do now is we want to substitute the second equation into our first equation. So doing so, we get that capital RT is equal to lowercase ct, and now I'm going to copy and paste these two to save us some time here. All right. So if we substitute this in for capital C2, you can see that we get this. Okay. Well, the next step is to understand exactly what alpha is. And alpha is our rate of growth of our RPI, or our retail price index. And these retail price index values are all of these Q values here. And these are the values that we know we are linking our cash flows to. All right, so how do you interpret alpha? So if you had a certain amount of money that you were investing in a bank account and it yielded you a certain interest rate, and then at a future date, you wanted to withdraw your money, you'd be expecting to withdraw that money plus interest. So you would expect to draw, let's say you invested X and your interest rate was I, and you held it for 1 year exactly. You would expect to draw X times by 1 plus I. So in other words, X grown by the rate of I. Now, you can think of alpha, or the rate of growth of your RPI, in a very similar manner. It grows your index values, because at a certain point in time, which is TL, which is the last known date, or the last date that we knew our indexation values, or our RPI value. Beyond that point in time, we will have to estimate the RPI values. And before that, we know exact values, so obviously we will not use alpha to estimate the values before this time, because we know the exact RPI values. And beyond that, we'll have to be estimating them in a very similar way that you would with interest, but now we are using alpha. So alpha is a rate of growth of our RPI. So if at one time period on from TL, we wanted to estimate the RPI, then we would take Q of TL, and we would multiply it by 1 plus alpha to the power of 1 time period on. If we wanted to estimate the RPI at time TL plus X, then we would multiply Q of TL and 1 plus alpha to the power of X. All right, so what we essentially do then is we grow this by alpha for X time periods to get the RPI at TL plus X. Okay. And the number that we are always going to be growing from is this last known value, because we're not going to be growing from something before that, because then we have an extra time period to estimate. Whereas at TL, we know exactly what our RPI was. It was the last known date, so it should be most relevant to the present. So we use our last known date rather than any dates before then. Okay, so with this now, we're going to try and see how we can manipulate this formula further. So any of these RPI values that fall beyond TL, we're going to have to estimate. So obviously Q of naught minus L is before TL, so we know the exact RPI value. But all of these three are to the right of our RPI at TL. So we have to estimate them. So in order to do so, we say that RT is equal to our nominal value, lowercase ct, multiplied by, now Q of T minus lag becomes Q of TL grown by the rate of alpha from TL to T minus lag. So the way that you figure out exactly how long you must grow your RPI from TL to your future date is if you take your future date, T minus lag, and you minus TL, it gives you the exact time gap between those two dates. So T minus lag is what we want to go towards, and we are starting at our last known date. So the difference between those is how much I must grow TL by in order to get to T minus lag. Okay, and then I'm going to do the same for these two RPIs. And obviously, Q of naught minus lag remains the same. Okay, so once again, we have Q of TL grown by 1 plus alpha, but now we are growing it to T naught from TL. Okay, and we know that that's true because we go from this point to this point, so the gap between those is T naught minus TL. So we're growing our index from this time point to this time point with alpha as our rate of growth. And then for Q of T, we're going to substitute in Q of TL multiplied by 1 plus alpha, and then now we are growing to this time point T from this time point TL, so minus TL. And the same logic that I used for those two will obviously apply again to this scenario. Okay, so let's see if we can cancel things and simplify things and then see where we're at. So we can cancel those two immediately, and then let's see what we can simplify. If we can cancel more, yes we can. So we can cancel those negative TLs in the exponent. Then we can cancel this 1 plus alpha to the power of t with that 1 plus alpha to the power of t, so I can cancel that exponent. And then let's see how we write this now. So we have our lowercase ct, our nominal value, multiplied by, and then in the numerator, we're going to have q of TL from here, multiplied by 1 plus alpha to the power of t naught. And then I'm going to say t naught minus TL. And you'll see why in a moment why I've chosen to put certain time points in certain exponents. And then in the denominator, we will have q of naught minus lag multiplied by 1 plus alpha to the power of lag. Because if we take negative lag, 1 plus alpha to the minus lag into the denominator, it becomes 1 plus alpha to the positive lag. Okay, so as you can see now, we are at a very similar point to our initial formula. You can see this factor that we multiply our nominal present value by to get our real present value. You can see this factor is exactly the same as the one that we've calculated. And we know that these are nominal values and those are real values. So essentially we're done here. We've derived the formula. And then you might say, okay, well, how come these are present values and how come these don't take into account the time value of money? So what happens now is you have your real values. So you have your nominal values times by this. And now if you multiply those nominal values by your certain factors to move it along in terms of the time value of money, then you get your present values or your future values or whatever point in time you want to move your money towards. But the point is that this represents our nominal values, this represents our real values, and this represents the factor by which we multiply our nominal values in order to get our real values. And that's what we've calculated. All right, so why now does this make sense? Okay, so let me move back up to this timeline and this initial formula to explain this. So if you look at these formulas over here, in order to get from our nominal value to our real value, we move from naught minus lag all the way to t minus lag in terms of prices. And then we move from t to t naught, our issue date, in terms of prices. So the net effect of these movements is that we move from naught to t naught. And if you don't believe me, I'll quickly prove it to you. So t minus lag minus naught minus lag, our lags cancel and we get t. So this vector over here, if we treat it as vectors, is t in that direction, in the positive direction, so positive t. And if we treat that as a vector, then we move from t to t naught. So this vector would then be t naught minus t, but that is in the negative direction, so we leave it as that. Okay, so obviously in the positive direction you have t minus t naught, but it is in the negative direction, so you multiply your negative in, and then you get negative t plus t naught, and then obviously that's equivalent to t naught minus t. All right, so we have two vectors now, and if we add them together, then we are hoping to get that vector. So t naught minus t plus t, those t's cancel, and we simply get t naught, which is the exact same magnitude as that vector over there, which is t naught. Okay, as we move from 0 to t naught. Okay. So why was it valuable for me to show you this? Well, I wanted to show you that we got this formula from these two formulae, and essentially what they meant on the timeline and what the net effect was, because now we can understand this formula and remember it much more easily. So how do we do that? Well, if we are essentially moving from time naught to time t naught, then we can multiply the cash flow at this point, which let's say it's a nominal cash flow of CT, and its price at this point is in the retail price index, represented in the retail price index at that point is Q of naught. Then we divide by Q of naught, where we are coming from, and we multiply by where we are going to in terms of prices. So we want to express it in terms of prices at T naught, at the purchase date, because that's what we're interested in. We're buying it at the purchase date, so we want it in terms of prices at the purchase date to express our real yields and real values. So that is Q of T naught. So that's essentially what we're after for our real values. So then I encourage you then to think about those two, the numerator and denominator, in terms of those numerators and denominators. And you can see then that it would make sense. Because if we increased TL by our RPI growth rate of alpha, then we would have to move along in order to get to T naught by T naught minus TL. So this clearly equals to that numerator. And then let's think about this denominator. So if we wanted to get to Q of naught, given this value over here, given Q of naught minus lag, then we would have to grow it by our RPI growth rate of alpha for a time period of lag. And then you can see then that that denominator certainly equals that denominator. But now you say to me, how earlier did you say we are only going to grow from our RPI at our last known index, because we actually know what our RPI is at our indices before that. And here we have Q of naught, which is an RPI that is before our last known index, so we know it. So why don't we just use Q of naught? So what I'm trying to explain here through this explanation or this formula, to understand this formula as a way of remembering, is that it's simply a way of remembering. So we don't actually grow this Q naught minus lag by 1 plus alpha to the lag. That's actually the wrong way of thinking about it. It's just a helpful way to remember it. The only way that we arrived at that formula is through this long process. And as you can see, the lag appeared through a completely different calculation with the t involving the t minus lag. So don't give it too much importance, the way of remembering this formula and involving this lag with this naught minus lag, because that's not actually how it came about. It's just a way of remembering. Okay, so I've given you a way to remember this, and I've shown you how to derive it and what it means. Now let's try and use it in an example. All right, so in this question, it says on the 1st of July 2002, the South African government issued an index-linked bond of term 7 years. Coupons are paid half-yearly in arrears on the 1st of January and the 1st of July each year. The annual nominal coupon is 2%. Interest and capital payments are indexed by reference to the value of an inflation index with a time lag of 8 months. You are given the following values of the inflation index. and then you can look at the table there. And then it says the inflation index is assumed to increase continuously at the rate of 2.5% per annum, effective from its value in May 2003. An investor paying tax at the rate of 20% on coupons only. So why does it say only? It's because we're not actually dealing with capital gains tax in this scenario. That's a topic for another video. And then after that says purchased. So an investor purchased the stock on the 1st of July 2003, just after a coupon payment had been made. So the purchase date is different to the issue date. It's 1 year after the issue date. Then it says calculate the price per 100 Rand nominal to this investor such that a real net yield of 3% per annum convertible half yearly is obtained, and assuming that the investor holds the bond to maturity. Okay, so a useful place to start is with our formula. So let's go ahead and copy it and paste it in. All right, and let's see what values we can get from this information to make this formula as easy as possible to calculate. Okay, so first let's draw a timeline so we can identify all of our RPI values at the particular points in time. Okay, so the first important date to note is the issue date of this bond, which is the 1st of July 2002. So that is time naught, and it is the 1st of July 2002, 1st of the 7th, 2002. And another important date to note is the 1st of July 2003, which is when we purchased it. So this is the purchase date, T naught. It's obviously important also to fill in these inflation index values that we know. So these are the ones that we know for certain. So the 1st of November 2001 would fall somewhere over there, and that RPI value would be 110. And then the RPI at the 1st of May 2002 is also before the issue date, and that value is 112.3. And then we have the next one at the 1st of November 2002, which is 113.2, and then we have 113.8 at the 1st of May 2003. And then 7 years after T equals to naught, after the issue date, the bond matures. Okay. So we have some important numbers on here. So let's see what's in this formula that we don't know. So we don't know TL. So TL is the last known date of our RPI before purchase date. So purchase date is T naught, and the last known date then is this, where this 113.8 lies, which is the 1st of May 2003. So that would be TL. Okay, so then what else is in here that we don't know? Well, we don't know lag, so we can say that the lag is equal to, so we can find it somewhere in the information there, a time lag of 8 months. So we have lag is equal to 8 months. Okay, what else don't we have? We don't have alpha. So alpha is equal to the rate of growth of our inflation index, which is 2.5%. All right, and what else do we not have? Okay, so what is Q of naught minus lag? Well, Q of naught minus lag is the inflation index 8 months before issue date. So 8 months before 0. So what is 8 months before 0? So that's 8 months before July, and if you work that out using your fingers or whatever method you want to do, writing out your January, February, March, whatever on your page and counting along like a frog leaping along, you would get to the 1st of November 2001. Okay, so Q then, so Q of naught minus lag then is equal to 110, the RPI 8 months before issue date. And what is the RPI at TL? So Q of TL is equal to 113.8. Okay, so we have most of these values over here. We just don't have this present value, the nominal present value using the real interest rate. So the nominal present value using the real interest rate, and by the way, the real interest rate, we know that to be 3% per annum convertible half yearly. Take careful note of that, because that's an easy way that they can catch you. They could have said effective, which would then be different to convertible half yearly. Okay, so this present value, our nominal present value, using our real rate of interest, must take into account all the cash flows that the investor will be receiving. Now, if the investor purchases the bond at T0, which is 1 year after issue date, then he will not be receiving all of the coupons. And in fact, it says in the question that an investor purchased the stock just after the coupon payment had been made, and he bought it 1 year after issue. So he had missed out on 2 coupon payments because the coupon payments are made half yearly. So he's essentially has 6 years left until the bond matures. And if coupon payments are made half yearly, then he still has 6 times by 2, which is 12 coupon payments to receive. And what are his coupon payments? Well, he receives coupon payments of 2% per annum, but twice a year. So 1% every half year. And if there is a price of 100 Rand nominal, then 1% of 100 is a 1 Rand coupon for every 100 nominal at every half year interval. But you must remember that he's paying tax on that. So he's only getting to keep the remaining of that coupon. So if he pays 20% tax, then he keeps 80% of that coupon. So his coupon then is equal to 2%, which is our annual coupon rate, but divided by 2, because we are receiving coupons half yearly, multiplied by the price, the nominal price. So we are doing this in terms of 100 nominal, so the nominal price then is 100, and then times by the leftover after tax. So that's 100 times by 1 minus 0.2, or 100 times by 0.8. And if you calculate that, you should then get that the coupon that he gets to keep is 0.8. All right. So the coupon is 0.8, and he receives these half yearly in arrears for 6 years. So using actuarial notation for annuities, this is going to be a 12, an annuity in arrears, and the interest rate at 3% per annum convertible half yearly. So at 3% over 2. Okay. And don't forget that he also receives the redemption value, which we are assuming he redeems this bond at par. So at maturity, he gets paid back his nominal value or of his investment, which is 100 Rand. But we must present value this by discounting it 12 half years. So V12, where V represents 1 plus 3% over 2 to the negative 1. Okay. So we have pretty much everything to go ahead and calculate this. I'm going to substitute in the values, and then you can simply go ahead and calculate it, and I'll tell you the answer. So we have that our present value at our real rate of interest is equal to, now for Q of TL, we're going to substitute in this, 113.8, and we are growing that at 1 plus 2.5% for T0 minus TL. Okay, so this is T0 and this is TL, and the time period between there is 2 months, and remember that 2.5% is an annual rate, so this grows for 2 over 12 months. Okay, and then, so we've sorted out that numerator, let's sort out this denominator here. So Q of 0 minus lag is 110, and then we grow that by 1 plus alpha to the lag, which is 1 plus 2.5%, and our lag is 8 months, but don't forget, we can't just put 8 because that would be 8 years, because this is a yearly growth rate, so it's 8 over 12 because it's months, and then we multiply by this present value over here, 0.8, and then this annuity represents 1 minus V to the 12 over 3% over 2. So that is exactly the same as that annuity. And once again, where V is equal to 1 plus 3% over 2 to the power of negative 1 plus 100 times by V to the 12. Now, if you go ahead and type that into your calculator, you should get that the present value using the real interest is equal to 94.38 Rand per 100 Rand nominal. So I hope you found this video useful and interesting, and if you did, please don't forget to leave it a like and subscribe to my channel. And if you have any questions, please don't hesitate to leave a comment in the comment section below. I'll do my best to attend to them. Thank you.